So I tried making an FPS in 3.js, and let's just say it was a wild ride. Making an FPS like Counter-Strike takes a lot of work. But can a browser even handle something like that? Well, games like Crunker have blown up in the past few years, so it's definitely possible. This is my old FPS in 3.js called Enari, made back in 2021. It was a simple single-player demo. Now let's try remaking something like this, but with recent tools. We're going with vanilla 3.js, not React 3 Fiber, and TypeScript for this project. To keep things simple, we'll use a physics engine, so we don't have to reinvent collisions from scratch. Enari was built with Ammo.js, but this time, we're switching to rapier.js. It's easier to use in my opinion, and the documentation is excellent. All right, let's go. We're starting with an empty Vite project. Here, I'm using Bun, which is similar to Node.js, but it won't make a huge difference for what we're doing. We don't need React or anything like that, since we're using vanilla 3.js. Since this is an empty project, let's go ahead and remove the default files Vite created for us. Now let's add 3.js and create a basic scene. We can just copy the code from the 3.js README to get started. Once we see something rendered, we'll know it's working. Cool, looks like it's working. We can't keep everything inside a single main file though. Let's split things up a bit. It'll make it way easier to work with in the long run. Our scene is up and running. Now a good next step is implementing pointer lock. This keeps the mouse from leaving the window, an absolute must for any FPS. We can track mouse movement using this JavaScript event. These values can be used to rotate the camera. Awesome, it works. The camera is just another object in our scene, which means we can move it. Let's make it respond to player inputs. We're moving. This already looks way better with the lighting and shadows, but we're going straight through everything. There's no collision yet. Moving the camera directly isn't the best approach. Instead, we need a player class with its own position, and the camera will follow the player. That way, we move the player, not the camera. This is where physics comes in. Remember when we talked about Rapier.js? Now it's time to use it. By following their documentation, we can set up the physics for the ground and even add collisions for objects like the cubes we already have. I think the most important thing to get right here is the game loop. We're not using set interval. Instead, we'll use request animation frame. This is the only loop we need, and it updates everything in the right order. For the ground and boxes, we can use a cuboid collider to match their mesh. Right now, both have fixed rigid bodies, meaning they won't move. Later, we can make some objects dynamic to allow for interactions. For the player, a capsule collider is a great choice. It's the standard in many game engines, so it makes sense to use it here too. Capsules help prevent the player from getting stuck on small edges and make movement feel smoother over obstacles. We have collisions. But what if we could automatically generate collisions from a loaded map? That would make our workflow much better. We could design the map in Blender, import it, and let the game handle collisions automatically. When it comes to collision detection, the vertices are crucial because they define the geometry of the object. We can use them to approximate the model's shape for the physics engine. A Trimesh collider is a collider that uses vertices and indices to create a collision shape. It's useful for handling collisions with complex 3D models without needing to simplify them into basic shapes like boxes or spheres. We can now import any map from Blender, which is super efficient because Blender becomes our map editor. Now let's add jumping. We just need to set the Y velocity to make the player lift off the ground. Right now we can jump infinitely. To fix this, we need to check if the player is on the ground before allowing a jump. We can do that using a raycast pointing downward. At first I made a mistake. The ray was detecting the player itself. I had to make sure it ignores the player's collider and only checks for the ground. Now it's time to add the weapon. It will be a mesh positioned in front of the camera, giving the effect that it's always in the player's view, just like in most FPS games. There are plenty of weapon models available online. Let's grab some for testing. To make sure the weapon always stays visible, we make it a child of the camera. This keeps it positioned in front of the player's view. Right now, the weapon just sits there. It doesn't feel dynamic. Let's add some movement. A slight bob when walking, sway when turning, and bounce when jumping. We'll use the player's velocity to drive this and smooth it out with lerping. This is coming together. The lighting needs a bit of work. The sky can be better, and 3.js already has a solid sky shader we can use. Let's polish. Time to make this more realistic. We need arms, so let's find some 3D models online and bring them into the game. Our models are kind of heavy, and for a web game, that's a problem. We need fast load times. The easiest fix? Optimize textures. I just checked, and they're in 2048 by 2048. Way too much for what we need. From 3 megabytes to 140 kilobytes. That's around a 95% reduction, which is huge for keeping the game lightweight. pistol model is done. Now I'll bind it to the arm rig so it moves correctly. Just adding an idle animation gives life to the weapon. We still need to add shoot, switch, and reload animations using Blender. It's a bit of a pain here. As soon as you have two animated rigged meshes, the GLTF animation tends to fall apart. We've got a memory leak. Every time I switch weapons and come back, the game reloads the weapon into memory. That means we're stacking up duplicates, and it's going to kill performance if we don't fix it. What I did was simple. I created a pool of weapon meshes when the game starts, and instead of reloading them each time, I just reuse the ones from the pool. Weapon switching looks weird right now, but that's normal. We haven't added the switch animation yet. Just like in Counter-Strike, it should play a smooth animation, not just appear instantly. All right, time to jump back into Blender and work on that animation. Okay, the switch animation is in place. It doesn't need to be super realistic right now. We can tweak it later since I always save the .blend files. In games like Counter-Strike, when you shoot a gun, there's a quick visual effect at the barrel called a muzzle flash. It's usually a particle or a sprite that makes the gunfire feel impactful, like a quick burst of light. A simple way to do it without using too many resources is to use a texture. Just display it for a brief moment every time you shoot. It's efficient and easy to change later since it's just an image file. Since the muzzle flash is just an image, we're using a simple plane geometry to display it. If we use world position for the muzzle flash, we'd constantly have to reposition it every frame to match the gun's movement. Instead of placing the muzzle flash in world space, we're just attaching it directly to the weapon mesh. That way it automatically follows the gun, respects all the bobbing and sway, and always appears in the right spot. Because the muzzle flash is just a textured plane, it's really easy to change. We can switch textures on the fly and tweak the style. Just like we did with the muzzle flash, we can fake smoke using textured planes. The difference is, this time we'll spawn multiple sprites in a loop and give each one velocity so they drift away over time. In my old FPS, I had bullet drops when firing, like casings falling out. We're bringing that back. We can actually reuse the same system we used for smoke particles. Spawn it, apply velocity. The only difference is, instead of going up slowly, it falls down fast. And this time we'll use a 3D model instead of a 2D sprite. One thing I've always loved about FPS games is the sound design. From the weapon switch to the reload, every sound is precisely timed. Those tight audio cues make everything feel responsive and immersive. At first it seems easy. We play a sound when the player switches weapons. But here's the problem. We are trying to match a complex animation with a single audio file. And worse, every weapon has different timings. Plus, most animations need several sounds, not just one. To get more precise audio sync, I split the full sound into separate clips. One for each action. This way I can time each one individually. Blender has this feature where you can place markers on frames. So I thought, what if I use those as sound triggers? I just name the marker with the sound file I want, and now I can sync audio directly from the animation. When playing an animation in Three.js, I can check the current frame in real time, so I just compare it to my sound markers. If there's a match, I play the corresponding sound. Low-end devices like Chromebooks are still out there, in classrooms, offices, and homes. Our games should still run smoothly on them. What we've done so far works, but let's ask a better question. Is there a more optimized way to handle this? There's this thing called draw calls in 3D rendering. The more draw calls you have, the worse your performance gets, especially on low-end machines. So let's look at what happens when I shoot. You'll see my draw calls spike every time. Why? Because every little smoke puff or muzzle flash I create is actually a new 3-dot mesh, and each one of those has to be rendered separately. That's a separate draw call. So even though I just press the trigger once, I might be triggering 30 draw calls instantly, and that's just for the particles. So I changed my approach. Instead of making a new mesh every time I wanted a smoke puff, I switched to GLSL particles. What does that mean? Basically, I send all the particle data, like positions, speed, size, and how long they last, to the GPU once, and then a shader draws all the particles in one go. That's the magic. Instead of creating 30 meshes and making 30 draw calls, I just do one draw call for all of them. When you shoot at a wall in most games, you'll usually see a bullet hole appear. Let's add that next. To make that happen, we first need to know exactly where the shot landed. Remember earlier in the video when we used ray casting to detect the ground for jumping? We're going to do the same thing here, but instead of casting down, we'll cast forward from the player's camera. If that ray hits something, we grab the hit point and simply place a bullet hole texture right at that spot. But wait. There's something really important to get right here. When we place a bullet hole on a surface, we can't just slap the texture there. We also need to rotate it correctly to match the angle of the surface. Without that, the decal would look wrong, like it's floating, clipping, or just facing the wrong way. So how do we fix that? Well, this is where something called a normal vector comes in. A normal vector is just a fancy way of saying, which direction is this surface facing? If you imagine an invisible arrow pointing straight out from a wall, that's the normal vector. Luckily for us, the physics engine already gives us the surface normal when we raycast. That means we don't have to calculate anything ourselves. We just grab the normal and use it to rotate the bullet hole the right way. I animated the reload in Blender, and while I was at it, I added all the sound effects too. So it looks good and sounds just right. One thing I've always loved about Source Engine games like TF2 or Counter-Strike is how great the movement feels. It's got that Quake-style responsiveness, so I dug into how to recreate that. I found this really detailed article that breaks down bunny hopping from a programmer's perspective. It covers things like air strafing, acceleration, and input handling. It was a bit complex, but I kept at it, and in the end, I got something that actually works. We've been using the pistol long enough. Let's upgrade to an AK-47. Same process as before. We grab the model, rig it, attach it to our arms, and start animating. This is where everything we built really comes together. All our systems for sounds, muzzle flashes, bullet particles, and smoke are modular and reusable. So adding a new weapon is just a matter of plugging it in. Plus, I can easily change things like magazine size and fire rate without touching the core code. The last thing we need is the knife. The way the knife is handled in Counter-Strike for the M9 is my favorite. Let's try to remake that one. The knife reuses the exact same weapon code. The only difference is that we don't emit bullets, and the raycast has a shorter distance to simulate close-range hits. With the engine coming together, I thought it was time to play around a bit. I added some water to the scene using a pre-made shader from Three.js, and then I thought, wait, we already have particles for bullet impacts. What if I reuse those for splash effects when shooting the water? I tried it, and it kind of worked. It actually looks decent. The thing is, this kind of effect needs to be implemented properly. Right now it just shows a splash, but what we really want is to detect what kind of surface we're hitting, like water, wood, metal, or concrete, and spawn the right particle effect based on that. That would be a huge improvement to the realism. I usually post clips of the projects I'm working on over on Twitter, mostly to get feedback and see how people react. I shared that water test there too. Feel free to follow if you're curious. Do you guys know the game Superhot? It's that FPS where time only moves when you move, and it feels insanely smooth. Have you ever wondered how the developers made that slow motion effect? Remember when we talked about delta time? It's basically how much time has passed between each frame. For example, my monitor runs at 144 Hz. That's 144 frames every second. So each frame takes about 1 divided by 144 seconds, which gives us a delta time of roughly 0.006. Now here's the cool part. If I divide that delta time by 4 or 8, the game thinks less time has passed each frame. So everything moves slower, like we're in slow motion. Bullets fly slower, animations take longer, and the whole game feels smooth and slowed down. I've started messing with post-processing. That's just a fancy term for effects applied after the main scene is rendered. Stuff like bloom, blur, and color grading to give the game more style. There's a possibility to add dynamic rigid bodies in the physics engine, so I started experimenting with cubes, making them dynamic so they respond to forces and collisions. When I do a raycast to check where my bullet hits, I can also get the rigid body of the object I hit. If it's a dynamic object, like a crate or something that can move, I apply a force to it. The force is calculated based on how far the object is from me and the weapon's damage. course, I had to try Dust too. This can't be a Counter-Strike clone without it. I grabbed a map just to test things out, and honestly, seeing it running in my engine made me start dreaming about multiplayer. If you're interested in the project, feel free to subscribe. I'll be posting more videos as I build the multiplayer system. You can also try the current version live at notstrike.online. Thanks for watching.